Today we are starting Unit 5, Graphing Inequalities and Systems of Equations. So in Unit 5 you're going to see a lot of what you saw in Units 3 and 4 with quadratics and their graphs. But we're also going to work with inequalities now. So the graph will look a little different. And we'll be looking at different types, including linear inequalities. So our first lesson here, 5.1, we have solving quadratic inequalities in one variable. So let's just dive right in. When the equal sign in a quadratic equation is replaced with an inequality sign, just a reminder, inequalities are less than, greater than, less than or equal to, and greater than or equal to. A quadratic inequality in one variable is formed. So a quadratic inequality in one variable can be written in general form as so. We have ax squared plus bx plus c is less than 0. And then we have it as greater than 0. And we have less than or equal to. And lastly, we have greater than or equal to. Now, a, b, and c are all constants, and a cannot equal 0, because if a equaled 0, our x squared and all of them would cancel out. And we would no longer have quadratic equations. We would be looking at linear equations now, which we will look at in our next lesson. But for now we are still working in quadratics, so a cannot equal 0. Let's take a peek at some examples. Example 1. Look at y equals x squared minus 2x minus 3, a quadratic equation. And it's already graphed there for us on the right hand side. First it's asking, when is x squared minus 2x minus 3 equal to 0? So when it is equal to 0, we're looking at our x-intercepts, right? When it crosses the x-axis and our y is now equal to 0. Well, in the graph here, it displays it nicely. It displays it at the point here and a point here. Now those are points when x equals -1 and x equals +3, it looks like. So the quadratic equals 0 at those 2 points. Our next question is asking us when it is greater than 0. So that's when it's above the x-axis. So the quadratic is displaying above the x-axis here and here. So the boundaries for when when the quadratic is greater than 0 are when our x values are either greater than +4 and when our x values are less than -1. Because it just keeps going out and getting wider and wider and wider and wider when it's above the x-axis. Lastly, it's asking us when it is less than 0. So at this point we want to say when it's below the x-axis. So when the quadratic is less than 0, it is within these points here. That is when it's being displayed less than 0, below our x-axis. So we can say that our quadratic is less than 0 when it is between -1 and +4 at this case. So when we're looking at whether the graph is below the x-axis and above the x-axis, we're going to have one being in between a set of points and one continuously growing out from a set of points. So here we had above the axis being growing and getting larger. And below the x-axis, we were in between a set of points. So next we need to look at how we can actually go ahead and solve quadratic inequalities. And there are a couple steps that we need to follow in order to do this. So let's take a look at those. So our steps are, number 1, move everything to one side of the inequality and factor it. Okay, we remember how to do that from Unit 3. Number 2, using the zeros, sketch the graph. So the zeros are also our roots or our x-intercepts, and we find those by factoring, and then we can use them to sketch the graph. Number 3, write the solution to satisfy the inequality. So that's where it's going to be either less than 0 or greater than 0. So we're looking at whether it's above or below the x-axis. And lastly, test points from each region to check the solution. Now this is a must-do. I've always been very picky about checking our solution, so we need to continue that in this unit. So let's just go through a couple examples and get a better feeling of how to solve the quadratic inequalities. Example 2. Solve the inequality 3x squared plus 2x minus 1 is less than 0. So our first step says move everything to one side of the inequality and factor it. Well, luckily enough, it's already done that for us. So let's just go ahead and rewrite it. We have this. So that's done. Excellent. Now factoring it, we could use our AC method. And in this case, we have an A of 3 and a C of negative 1. So we're going to have an AC of negative 3. Now what two numbers multiply to negative 3 and add to, this should be a positive 2, add to positive 2? In this case, I would use the factors of positive 3 and negative 1. So we need to rewrite our equation. This is a bit of a review from Unit 3. We have 3x squared plus 3x minus x minus 1 less than 0. Now going ahead and splitting up our equation to find common factors, we have a 3x here, leaving us with x plus 1. And here we can take out a negative 1, leaving us with x plus 1 as well, all less than 0. Well, from here we can find our factors are x plus 1 and 3x minus 1 less than 0. And hence our roots of the equation here are x equaling negative 1 and x equaling 1/3. Now step 2 asks us to use the zeros, which we just found, the roots, and sketch the graph of this quadratic. Well, since we know that we have roots at negative 1 and 1/3, those are going to be our x-intercepts. Now here's where a little bit of difference comes into play. We know that we're looking at a graph less than 0. So that means that it's not including when it is equal to 0. So instead of filling in dots at our roots here of negative 1 and 1/3, we're going to have open dots. So I'm going to draw an open dot at negative 1 and 0 and 1/3 and 0, which is probably around here. And those are our x-intercepts, our roots. But they are open because we're not including them in our solution. Now from here, I'm just going to do a rough sketch of what I think the graph would look like. I do know that it does cross the x-axis at negative 1, because looking at our graph, we learned in Unit 4 that when it's in general form, the constant is the x-intercept, which is negative 1 in this case. So I'm going to try and make a vertex down right around here and then kind of just go up, cross at negative 1, and then just kind of look like that. That's kind of what my parabola would look like. Now remember, it's a sketch, so it's a bit of a rough drawing. It's not completely accurate. So, moving on, we have step 3. Write the solution to satisfy the inequality. So, from earlier, we know that we want 3x squared plus 2x minus 1 to be less than 0. So that is when it is below the x-axis in this case. So looking back at our graph here, I also forgot to note that it is a graph that opens up because our leading coefficient is positive. So just to make a note of that, it does open up. Okay. Well, we want to know when it is below the x-axis, and we can see that it's below the x-axis in between our two roots here. So going down to write our solution, we can say 3x squared plus 2x minus 1 is less than 0 when x is less than 1/3 and greater than -1. Has to be between these 2 points. Awesome. But we're not quite finished yet. Remember, we need to test points from each region to check the solution. So, making a note, how it says each region, that means there's 3 regions. There's the region when it's smaller than -1. There's the region that it's in between, and then there's the region that it's going to be greater than 1/3. So, let's go less than -1 as our first region. Let's just try a number that we can work with easily. Let's go x equals -2 in this case. So, going in and plugging it into our original of 3 -2 squared plus 2 times -2 minus 1 less than 0. That was our original. Here we're going to get 12 minus 4 minus 1 less than 0. Well, this actually comes out to 7, which is not less than 0. So no, that is not part of the solution, and that's what we want, so that's good. The next region we can try is when it's in between -1 and 1/3. Try x equaling 0 because it lies in between and it's an easy point to solve with. We got 3 0 squared plus 2 times 0 minus 1 less than 0. Well, this comes out to just minus 1 is less than 0, and yes, that is what we want. So this is a good solution here, which we've already determined to be our solution. Lastly, we need to check when it's more than 1/3. Well, let's just try x equaling 1 in this case. Well, we get 3 times 1 squared plus 2 times 1 minus 1 less than 0. This actually comes out to 4 less than 0, which is not correct. So yet again, we're saying no. So from here, we can see that we did all our work correctly, and we got the right solution where 3x squared plus 2x minus 1 being less than 0 in between the points of -1 and +1/3. So that's how we go ahead and solve a quadratic inequality in one variable. Now let's do another example for extra practice, but I encourage you to go ahead and pause the video and try to work through it on your own and come back to the video for reference. So let's just do it. What do we got? Here we have -8x is less than or equal to -3 times x squared minus 1. Alright, our first step wants us to move everything to one side of the inequality and factor it. So let's do that in steps. We have our -8x less than or equal to, well, feeding our chickens, we're going to get -3x squared plus 3 here. Solving it to one side of the inequality, we get positive 3x squared minus 8x minus 3 is now less than or equal to 0. So, can we take out any common factors right away? Unfortunately, no, we can't in this case. So we need to move on to our factoring. We have our AC here. Our AC is 3 and -3, which becomes -9. Now what multiplies to -9 and adds and subtracts to -8? In this case, we will have -9 and +1 as our factors. So let's rewrite our inequality. We have 3x squared minus 9x plus x minus 3 less than or equal to 0. Splitting our equation, we have a factor here of 3x and leaving us with x minus 3. And then here we have taking out just a 1, leaving us with x minus 3 less than or equal to 0.